Okay, let's get into this. We're doing a deep dive today that connects something maybe from a college math class, calculus,
Right.
to something, well, surprisingly practical and tasty, actually.
Yes, definitely. We've been looking through some materials, some documents, exploring how calculus gets used out there.
Yeah, and specifically, the focus is on differentiation, finding derivatives.
Mm-hmm. And what's really interesting in these sources is how they link these, let's be honest, sometimes abstract math ideas
Mhm.
to a very hands-on process. So our mission really is to understand how calculus helps figure out the rate
The rate.
that juice gets extracted from fruits, agricultural fruits.
And the source is really honed in on two specific ones,
Yeah.
pineapple and mango.
Yeah, pineapple and mango.
So think about it. If you're maybe wrestling with calculus right now, doing derivatives, rates of change.
Mm.
All very theoretical, right?
Usually, yeah.
Well, this deep dive kind of shows you what that looks like in, the real world.
Mm.
It's pretty fascinating seeing the math actually do something tangible.
It really is. The core idea from the material is using that concept, the derivative, to, well, quantify the juice extraction.
Quantify it. How so?
Well, think about pressing a fruit. You get a certain amount of juice, right? Of volume.
Sure.
And that happens over a certain amount of time, or maybe depends on the pressure you apply.
Okay, yeah. Volume over time.
Mm-hmm.
That sounds like a rate.
Exactly.
Yeah.
That's the connection. It sounds a lot like a rate of change, doesn't it?
It absolutely does.
Yeah.
And that's what the sources dig into. They
Yeah.
talk about models where maybe the amount of juice you collect is a function.
A function of time, perhaps.
Right. Or pressure. And if you want to know how fast that juice is flowing at any specific moment,
Uh-huh.
like the instantaneous speed of juicing,
Oh, yeah. The speed of juicing.
that's where you need the derivative of that function.
Precisely. It's not just about, how much juice you end up with in total.
Right.
For things like processing efficiency or maybe even quality control, knowing the rate, how fast it's coming out during different parts of the process, that's actually really important.
Mm.
And these sources get into how differentiation gives you that number, that measurement. Like how many milliliters per second are we getting right now?
That makes the whole idea of a derivative, that instantaneous rate,
Yeah.
suddenly feel very, very practical.
It does.
It stops being just about slopes on graphs and becomes about, I don't know, optimizing a machine or understanding how the fruit itself behaves under pressure.
Maximizing how much juice you get without, say, damaging it.
Exactly. It really grounds those calculus chapters, differentiation, integration, in something you can totally picture, maybe even taste.
And connecting it sort of more broadly, measuring rates of change is just fundamental everywhere, isn't it?
Yeah, it seems like it.
Whether it's like flow rate in a chemical plant or data speeds, or like we see here, how fast you're squeezing juice out of a mango, calculus gives us the tools.
So wrapping up what we found in the material, what's the takeaway?
Well, I'd say it shows that calculus, and differentiation specifically, isn't just theory stuck in a textbook.
Right.
It's a powerful tool. It helps us model and understand and maybe even improve our really practical processes.
Like getting juice out of pineapples and mangoes more efficiently,
Yeah.
just by measuring how fast it's flowing.
It's a prime example of math describing and helping us tinker with the physical world.
Absolutely.
Yeah.
Okay, so that leaves you, our listener, with maybe a final thought to chew on. Where else is calculus hiding in plain sight around you? Think about other everyday things where the rate matters.
Like how fast your coffee cools.
Yeah, or traffic flow,
Yeah.
or water filling a tub, anything changing over time. Chances are, calculus is somewhere in the background helping us understand just how fast things are really happening.